the go live button because the lesson is going to be recorded.
And live streaming.
Yes, and live streaming. Where we are on air, but I don't have the projector yet. Can you please switch on? Can you please switch on the projector? So today we will talk about the event loop. So today we will talk about as the introductory paragraph here reads, usually when we build applications with JavaScript to be run in a browser, you may hear the term event-driven programming. What this means is that the flow of execution of our application is driven by events. If we are to talk a little bit about history in order to make it a little bit clearer what events are, let's go a few years back. Of course, we still use it. Up until the 80s, we had mostly command line interfaces, right? Like the command line we have in Windows, and we sometimes use. Then came along the character-based user interfaces, like the ones we still see in perhaps when we edit the BIOS. When we want to make changes to the BIOS of our computer, we press the delete button or F8 or whatever, and we get into this interface. This is a command. This is a character-based interface. I have actually created a couple of these interfaces in the old days, and we did that by bringing together this kind of characters, see, in order to create windows and make them look like real boxes, etc. It was really fun, actually, back those days. So when these interfaces came along, a new type of, let's say, thinking about our application was emerged, which was event-based, event-driven programming. So what our application does is first presents an interface to the user, perhaps with buttons, inputs, etc., and the application stays still until the user does something. For example, if the user clicks a button, then we attach some behavior to the button. If the user expands a collapsed component or area in our application, then we do something else, or we may request a method from an API, etc. So this is event-driven programming. Examples of events are clicks of buttons and load events from XML HTTP requests. So how is this done? Is that we attach listeners to certain types of events, of any type of events. An event listener or the event listener attaches an event handler to the event. So the event listener will listen for events, and when the event occurs, it triggers the event handler. Sorry, 1 second. Sorry, 1 second, because this one code is very important. Ναι. Ναι. Ωραία. Όχι, γιατί με το γραφείο. Τώρα θα πάω στο σπίτι.
This is a outline. What? This it's a outline, right? I don't understand. This is no? It is in outline. Nine. Yes.
Sorry for the interruption.
This is on the notes week 9. This thing.
Yes, this is in GitHub. It's JavaScript-3 event loop, order of execution. Okay, there's this very nice video from Philip Roberts. He does an excellent job of explaining the event loop. Zohir had talked about the event loop 2 weeks ago, I think. And he pretty much explained what Philip Roberts explains in this very nice video. And Philip Roberts, by the way, has created a fantastic little application that visualizes the way JavaScript and the event loop, the JavaScript runtime and the event loop work internally. Check it out. So, event listeners listen for events, and when the event is triggered, the event handler is executed. The event handler is nothing more than a function. It's a simple function that it has it may or may not have arguments. Okay. One way to attach event handler to an element is by doing so in code, or we can do it directly in the HTML file. So let's see an example here. Let's start with a new folder. Sorry, what's that? Head, body. Okay, so let's run this. What I did here is I placed a button and I set the button, this is an HTML element, and the element has a property named onClick, and I set this to my function button clicked, right? And let's run this. What happened to my HTML code? Where is my button? What am I doing wrong here? Body. Okay, that's strange. I simply did a refresh and everything appeared. Perhaps I hadn't saved the HTML. This is why, because in the place where the control button should be, there is a function button on this laptop, so I clicked, so I pressed, instead of pressing Control S, I pressed function S. Alright, mystery solved. So, reload the page, and yes, let's simply click the button. Okay, so I clicked the button and the alert appeared. Alright, so the function in this context, this function, we call this function as an event handler. It's a function that handles the event. Which event? The on-click event of the button. So far so good. So this is the one way of adding an event handler to an event. Another way is to do it with code. So let's have another button here. To do that, we have to put an ID to the button so that we can uniquely identify it and fetch it in order to attach the handler. So I set the ID to be my button, and inside my JavaScript, let's copy paste this code. But instead I'm going to do it. No, let's call the function. Yes, let's add sync on click listener. So I'm getting the button with ID my button, and I get the element. Let's do it in distinct steps so that it's clear. Let's button element. This is an inline function declaration. Is it okay with you? I can alternatively I can create a separate function here for things to be super clear. And let's simply pop up another alert. Let's not talk yet about sync and unsync. and async on button click. So here I put on button click.
Is that sync time on? It's not anymore.
Button click. On button click. I do not need this. And let's put a debugger keyword here to see what happens. Okay, button. In this function, we get the element with ID my button, and we attach an event listener on it. Click on button click, and when the user clicks on the button, then this function will run, which will pop this little alert here. So let's see this in action. Sorry, one more thing. I will not attach right now the handler so that you can see that at first the button will be dead. So I click this button. Where is my alert? We accidentally deleted something. Button clicked. Yes, I accidentally deleted the function. Button clicked, button clicked. And why didn't I get an error? I got an error in console, yes. So let's refresh the page. I don't care about the debugger right now. I click the button and first button was clicked. But if I click this button, nothing happens. Why? Because first this button has no event handler attached on it with syntax like this. And second, because the function that attaches the handler to the button has not been run. So if I run it, refresh, F8, click, and my button was clicked. So you get to see the two different alternative ways of attaching handlers to events. One more thing that I wanted to mention here is that because we're going to need this information later on, JavaScript, as we know, is a single-threaded language, right? What does this mean? It's a single-threaded. But this means that only one function can be executed at any point in time. This is not true with other languages like Java, for example, or C#. So Java and C# have the ability to be running two or more functions at the same time. Of course, not exactly at the same time. Processor time is split among functions. So one thread gets a small piece of execution time for the. Let's assume that we only have one processor, right? Let's not take into account multi-core processors yet. Let's assume that we have an old processor with a single core, and that we need to run on it two or more threads. So how is this done internally? Execution time is simply split among threads, and each thread can run one function at a time. So multi-threaded languages can have many threads. There is, of course, an upper limit on how many threads you can have, and we'll talk about that. But for each thread, we have a call stack. Okay, JavaScript has only one thread, so we only have one call stack. Are you familiar with a stack, the data structure stack? What is a stack? A stack is this is a stack of post-its, right? This is a stack. I can remove the top post-it, and then I can put it back, or I can remove the other one, the next one, right? Stacks in computers have this restriction that you cannot remove an item below. You can only remove the first item, right? And only from top. And this action is called pop. So you pop the top item and you push an item onto the stack, right?
First in, first out, right?
First in, last out.
Or last out.
First in, last out.
Last out.
What we're talking about is a queue. When we have a queue, let's visualize a queue with a pipe. So if we put something here, we put things from here and we remove things from here. So if I put something here, one thing, two things, three things, this is the first, second, and third, right? If I pop the first item, this is the first item that got in. So first in, first out. Right? But a stack, we usually visualize a stack vertically. This is the first thing that's put. This is the second, third, exactly. Like a Pringles box. So you can only remove the top potato each time. And computers have the restriction that you cannot reverse the box. Get all the potatoes, the potato chips. So this is a stack. And how is a stack utilized in order for code to be executed? Well, this is how. Let's go back to our HTML. Whenever a function is to be executed, just the moment before it gets executed, it is put on the stack. For example, the first thing to be run here is which function? Which function will be executed first here in this code?
On button click, right?
On button click will be executed. Sorry, let me rename this.
Button click.
So, the HTML code is loaded in the browser, okay? And along with the HTML code, the browser reads the JavaScript, parses the JavaScript code, and the first line it parses is function add sync on click listener. Will this function be executed? I mean at the time of loading the page.
No.
Will this function be executed?
No. When the page loads.
Yes, it will be executed. And it's the only one that will be executed because we execute it here. We invoke the function right here, down here.
Okay,
Yes. Perhaps we can put it here. It's a good practice to put functions in the order of them being called. Just like if you see movies where they list actors in the order of appearance, it's a good practice to do that for functions as well. So the first function that appears in the movie is put on top. So perhaps I misguided you a little bit. So the first function that is going to be called, the first and the only function that is going to be called at the time of loading of the page is add sync on click listener. Okay. So let's try to visualize how the call stack works. First, when the page loads, take a look at this line of code. It's not inside any function, but the JavaScript runtime assumes that there is a function that contains all this code, which is called main, I think, or window, I'm not sure. Let's assume it is called main, but no, let me Google for a little bit to make sure. JavaScript. Main. Yes. Yes, I'm almost sure that's called main. Main function. Yes. The entire code block is effectively one big main. What this means that the JavaScript runtime assumes that there is one function that contains all this code, no matter how big the code is, and it's called main. So when the page is loaded, the browser will parse this code, and if any function is going to be invoked, then it will invoke it. But first, it will put in the stack the function main. So our call stack,
The function main is on the function, is on the code. What is it?
the function main is the function that the JavaScript runtime assumes contains all the code. So this is our call stack. It's called a call stack because it stores calling information about the functions. So when the browser first parses this code, when it starts parsing and executing the code, it will place one item in the stack, which is called main, right? And when it passes all the code, it passes the code twice, so that we will be able to call functions that haven't been parsed yet. See, because here we're invoking a function that has not been declared yet. It's declared just on the next line. So how does the JavaScript runtime knows that this function exists? It knows because it parses the whole text twice. The first time to make sure that everything is okay, and the second time to invoke a function. Any question? Okay. So, second parsing. It says this line of code. This is a function. Great, it says. I will execute the function. Let's make our stack a little bit wider. I will execute this function. It puts the function to the call stack. Add sync on click this. It puts it on the stack. It pushes the item of the stack so that we use the same terminology that we will be using in our code. And starts executing the function. Executes this line of code, this line of code. The function ends here. So when the function ends, it is removed from the stack. Okay. The item is popped from the stack. It continues. It has some declarations of other functions, but no other function is invoked. So the script ends here. And finally, since the main function ends, it is also removed from the stack. Quite simple, right? Let's see it. Let's have a little a quick example of functions, one calling the other here. Function outer, function inner, and these functions do nothing. I'm simply going to put a debugger statement here so that you see outer, inner, and one more level, innermost. Every modern browser has very helpful tools that facilitate the debugging of applications. So we simply hit F12, the debugging tools pop up, and we refresh the page, and the fun begins. Debugger, F10, F11 to go inside the function, right? Look, this is our call stack. Sorry, the name of the function was not main, is anonymous. See here? Anonymous. Let's do another refresh. So, this is the first line of execution, right? The very first line is a debugger statement. It's the very first line of code. So, we already have one item in the stack, which is the anonymous function, okay, which contains everything else. F10, the call stack still has one item, but
F10 we push F10 to proceed.
Yes, if you press F10, you proceed to the next line of code.
Okay.
I had explained F10, F11, but let's do that once more quickly. F10 is means step over. Do we have here? Yeah. These are the explanations. If I press F10, then I step over the function. So if the statement is a function, the function will be executed, but the debugger will not go inside the function. If I press F11, the function of course will be executed, but I will go inside the function to execute the very first line of the function. And I also have F11, which means continue the execution. I don't care, get out of the function and continue the execution. And we also have F8, which means continue execution until you reach another debugger statement. And if there is no other debugger statement, then the execution continues until all the code has been executed. So now I'm going to press F11 because I want to go inside the function named outer. See? The function, we're now in the first line of the function outer. Look at our call stack. The function has been placed at the call stack. Okay? And now the outer function calls the inner function, F11 again. Here's the inner function. See? The call stack. And as a final step, the inner function calls the innermost function. Here it is on the call stack. Okay? F11 again. We're still inside the innermost. But I press F11 once more and innermost finishes, completes execution. So look, it was popped out of the stack. F11 again, and now inner function completes, and that too was removed, was popped from the stack. And now outer function completes, and it's also removed from the stack. and I press F11 once more, and the call stack is empty. So the call stack being empty, this means that all the code has finished executing, right? The page has been loaded here, and there's nothing else for the JavaScript runtime to do. It sits idle, waiting for the user's input. What happens if I click the button? One thing that I did not mention is the event queue. So, apart from the call stack, we also have an event queue. We will visualize it with a horizontal pipe like this, because contrary to the stack, this is the call stack. This is last in, first out. This is the event queue, which is first in, first out. Okay. At certain points in time, the event queue will contain one or more events to be executed. So when the user clicks the button, what happens is that the browser will put this handler in the event queue. And we may have more items here. And this is our event handler. For the button. Now, the JavaScript runtime, if it is idle, and only if it is idle,
Not even idle.
it has finished executing all the code, and it doesn't have any other thing to do. It sits and waits. If it is idle, and only if it is idle, it will check the event queue. And if the event queue has one or more items, it will take them and execute them. So in that case, at this particular moment in time, there is one item waiting to be executed, which is the event handler from the button, right? So the event handler will be removed from the queue. It will be placed on the stack. And now the JavaScript runtime has something to do. It must execute it. Inside the event handler, there may be invocations for other functions. So this function, because the event handlers are nothing more than functions, may call other functions, and that other functions may call other functions. For example, if our event handler did something more complex than simply popping up the alert, perhaps it would call the function, let's say, get customer. All right. And that function called another function named called API, which would send an XML HTTP request that we saw in the previous lesson to our server, right? So we would have this call stack. And as soon as the call API function finished and returned its value, it would be removed from the stack. Then the get customer function would continue, and when it was finished, it would be removed from the stack. and then execution would continue at the next line of code in the event handler, and when the event handler finished executing, it would be removed from the code stack. Any questions so far? Let's see that. Let's see that in the debugger. It's pretty quickly. It's very easy to do. So instead of running the outer function in our anonymous method function, we will call it inside the on button clicked. Which is called button clicked. I click the button, right? And nothing happens. Why? Huh?
Have a written out there with the double field somewhere.
Where it, but
Not there. The first time you go inside the button click.
I accidentally deleted it. I'm really having trouble with keyboards of laptops. We do not need this debugger statement anymore. Okay. Click. Still nothing happens. Click me instead. Yes, because I put it on the first button. So I click the first button, button clicked. Where's our call stack? Ah, it's here now. So, look, this is the event. The event was triggered when I clicked the button. So it was first put in the event queue, then the JavaScript runtime removed it from the event queue, put it in the stack, pushed it in the stack, to use the same terminology, and it saw that it has an event handler attached on it. So it also pushed the event handler inside the stack and started executing it. And now button clicked calls outer. Here it is again in the stack. Outer will call inner. Inner will call innermost. Right? We have all these things, all these items now in the stack. Innermost finishes, it is removed from the stack. Inner finishes, removed from the stack. Outer finishes, removed from the stack. Button clicked, displays the alert, because we still have this line of code here. Okay. Button clicked finishes. And this is our event. It finishes, and we're finished. Right? Any questions so far? To demonstrate that JavaScript runtime will only process items from the event queue when it is idle, we will do a very simple experiment. We will make JavaScript runtime so busy with so much work so that it cannot process events from the event queue. Do you want me to do that now or after the break? Do you want to have a break now or?
Whenever you want. It's up to you.
Yeah, we can take the break right now.
Let's take a 5 or 10 minutes break and we'll do the experiment after the break.
So, in the break and before you take the break, let's catch up a little bit with the homework. So, actually, you three have been not coming to the class. Like Thomas and these guys are already up to date with the homework. You guys are really far behind. So, what you are going to do about it?
You will catch up.
How do you catch up? Because you are in week 4, JavaScript week 4. Or 3.
In JavaScript-3. Now we are in week 9, right?
Yes, we are in week 9.
Well, 5 more.
5 more. 5 more weeks. There is a lot.
We will find a day we'll be with you and we'll see what you will do first.
So, this is what I can do. From today, you have to come earlier, okay? And before the break, you have to finish your homework. Before like 12th of August, we have the break. And before the break, you have to catch up with the homework. Okay? So how you are going to do the homework? What time you want me to come and what time we can, how we can sort it out?
Let's say like 4:30 or
What?
4:30 morning and Wednesday.
Yeah, as far as I concern, like week 4, 5, 6, those are related, so you can do it. Okay, like after 6 it will be difficult. So would you try to give it a shot like from 4 to 6, and I will be on Slack whenever you find the problem. Like last time we did some, like you send me the screenshot, I give you some feedback as well, right? So please do this homework. After 12, like you have to show me something before the 12. You have like those days, and at least you cover until week 7, okay? And on the break, maybe you can cover week 8 and 9, and we'll see how we can cover. But I can only give you the time until the vacation finish. After vacation finish, when you will be start Node.js, because this is the end of JavaScript. If you don't finish all the JavaScript homework, we can't allow you to stay in the class. It's for everybody. If you are not up to date with all the JavaScript homework, because after the vacation we are going to start Node.js, and before the vacation I will be available here all the time. My Slack will be open all the time. Wherever you find difficulty, send me a message, send me a screenshot, do anything. I don't care. Call me. Or if you don't have money, send me a message. I will call you.
So next week, there will be no
4 days. It's on Slack. The vacation period.
Yeah, vacation will be on 12th.
Yes, next week we have lesson.
Yes, we have.
Node.js?
Yeah, not just first week. Yeah.
Ah, okay.
Yeah. Sorry, I'm so sorry. The first week 1 will be not yet. But I give them the time until the vacation finish, because if we go,
give them out. Maybe it's better to start Node.js, to go a bit later.
No, we can't.
Okay.
Because Node.js, since it's week 1 is mostly like introducing and how you cope with this thing, how you set up this environment, and very basic. But I can give them like before the vacation finished.
It's very difficult when you take up job newly.
Yeah, as I said, like start from today.
Yes, we'll try.
Have a break.
Thank you. We're actually
έχω πρόταση για το τυρό.
Δεν μου κάνει δουλειά παλιά. Να μην στη μάθανε κάτι.
Ξεχαστεί το κομμάτι.
Τι είναι όμως, κομπή.
Όχι.
Α, ναι, κομπή. Έτσι, αν έχω δουλειές, αν μαθαίνω κάτι, είναι μια εμπειρία. Αν και καλύτερα να χρειάζεται να δεις τι συμβαίνει το δεδομένο. Μεσό. Το χρυσό αέρα.
Clean the light, right? We clean the light, right? Yeah. So I have this small problem. You know, we have the classes, right? So, for example, this is I just create all the parts for this. Okay. As you know, we have like modules and database we need to then get one to right? So some of the classes doesn't have those types. I just created those things. How to class them, how to create. This is the new class, right? It doesn't have like the cars. So first of all, we have to create this one. It doesn't have the titles. You just need to add those links according to the mantra. This is what we take by those links. And for week 8, for class 8, class 6, 6 I updated as well. Exactly. I will do it. If it doesn't have the other, I will add them. You just add for the class 8. Okay?
You can invite me to the board. Just follow from the GitHub, right?
Yeah. Or you can, as an example, you can go into class 6 level and see how.
You can invite me also in those classes because I
Yeah.
have access.
Let me. For the class 8. The same is up with it. So you can follow the same and do the recording process.
You understand? So here every day, every time the class starts, you have your laptop. Who did the homework? It's not their fault that they are 4 or 5 weeks behind. It's your fault. It's your fault. You need to remind them. People are lazy. Everyone is lazy. You have to make them realize that this is not a child's game here. If you don't do your homework for 3 weeks, you're out, except if there's a problem. So we have a problem, we have a problem, the problem that we mentioned earlier, but they become homeless, yes, of course. That's a big problem. But otherwise, it's on you for them to do their homework. If they are not doing their homework,
create sort of things when it's better because they keep on bringing the phone when the class in previous class and because if we have the phone here, they know, and anyway they link to Romato to open them. Maybe during the class, especially for class 8, it's 8 to leave the phone like this. It's not the best thing, but instead of like keep on ringing again during the class, maybe to keep it like this. And tell them that they should come if they want to study, they don't have come for 6, as you know already. But for the class, they should come at 8, sadly. Okay? Because the previous class finishes at 8, so they should start come at 8.
Okay. let's write a function that will keep the JavaScript runtime really busy. Slow function. What I will do is that I will simply pass delay because I want to have the waiting time to be parametric. So this function, if I call it, look how this works. It takes an argument delay, it adds it to the current time, current date and time, because date.now contains will return the current date and time, and while this is delay will be added to the current date time and assigned to stop time, and while the current time is less than the stop time, which is going to be at some point in the future, what does this do? Nothing. It simply waits. These two statements are equivalent, right? So this function will wait, but it will wait. It will block the execution of the code while waiting. This is very important. Let's try it. I think this is in milliseconds. Let's put a debugger here because I don't remember if delay is expected to be in milliseconds or seconds. So let's put a 5 here. Refresh the page. No, it is in milliseconds. So I'm going to wait. I want to wait for 5 seconds. So 5 seconds is 5,000 milliseconds. And close the debugger so that I do not stop on the debugger statements and hit F5. So look what happens now. I'm going to refresh again. See? The page keeps loading for 5 seconds. Why? Because execution is blocked.
So that can be used for Windows like newsletter or things like that. Some pages when you enter, they say after 5 or 10 seconds, join our newsletter.
No, this is the purpose of the example, to show you that this code, this practice must be avoided because it blocks execution, and we'll see later on what we can do to work around this. But for the moment, look that while it executes, the page becomes unresponsive, right? No response here. But after it loads, then I get 1, 2, 3 alerts. Why? Because the events were put on the event queue. They could not be executed at the time that I clicked, but they were put in the event queue. And when execution, where should I put the debugger statement so that I can demonstrate this to you clearly? Let's put it, let's put it here. One debugger statement before I start executing the slow code, and one debugger statement just after the line that I want to play, to experiment with. And now I hit F12 to open up the debugger, F5 to reload the page, right? And now I will hit F8 to resume execution. I want, by pressing F8, execution of the code will continue until the next debugger statement, right? It goes inside the slow function, and now it executes. And while it executes, the page seems to be loading. And now it stopped again just after the slow function, but I think it would be more clear for you if I put that in the button clicked. Yes, button clicked. Why? You'll see why in a moment. So when I click the button, I'm going to get an alert saying before the slow function. Then the slow function will run and block execution for 5 seconds. And then another alert will pop up saying after the slow function, right? Let's try this out. I click the button, the alert pops up. So let's do that once more. So I refresh the page. I closed the debugger on the right so that I do not stop on debugger statements. If the debugger is closed, then the execution does not stop, even if you have debugger statements inside your code. So I click the button, the alert pops up, and now see the state of this button. It's depressed. And now the other alert pops up. But while this happens, the page is unresponsive. Okay. Let's try that once more. It has been clicked again. Okay, I click the first button, click OK, and then I click the second button. Let's see what happens. After the slow function alert pops up, I click OK. Shit. I don't put. Let's put an event handler to the second button as well. if I click button 2, the alert says second button clicked. Okay, so let's see that again. Click button 1, alert pops up, and then click button 2. Nothing happens. Why? Because because this code runs here. This code runs. And the JavaScript runtime is busy. It cannot process events from the event queue. But after execution of the slow function finishes, it goes out of the slow function, it returns here, right? Pops up the second alert, and when I click the second alert, okay, see what happens? Second button clicked. Is this clear for you? Any questions? But in the meantime, the user interface is unresponsive, which is bad practice for your user, because it may have happened to you. If you, let's say that you are viewing a web page in your application, right, and you click a button and nothing happens. What's something is going wrong?
Sometimes when you use pop-up windows, it doesn't let you, it doesn't leave the page. It's, some buttons were becoming unresponsive. So I guess something runs that blocks execution.
Are you referring to alerts like this?
Yeah.
Wait, this is something different, because alerts are modal forms, which means that you have to. This is a feature of alerts. A feature of alerts is that you have to answer, okay, cancel, yes, no, whatever, but you have to answer something to the alert in order for the execution to continue. This is referred to as push notifications in mobile applications.
Sometimes they don't leave you to leave even after you press the button. The whole page becomes unresponsive.
Some web pages, for example, Google Docs, or pages that receive input from the user, if it has not been saved and you try to close the tab or close the browser, will request a confirmation from you in order to leave the page. Is this what you are referring to?
No, not really. It's some pages with streaming borders and things like that. But,
yes, it may happen that pages become unresponsive. Yes, this is because a developer has not done a good job for the user. Most probably, yes.
When you click the first one,
the first button.
Yes.
Yes.
It will run. But
yes.
When you click the second one, it doesn't run because the first one is in loading, right?
When I click the first button, and after I click OK in the alert that pops up, we go inside the slow function. Okay? Here's the code. Button clicked. This alert pops up. And after I click OK in the alert, I go inside the slow function. Right?
Yes.
Which will be executing. Blocking will be executing and blocking execution of other code for 5 seconds, right? While this is executing, and because it is blocking, it prevents processing of events in the event queue. The JavaScript runtime will only process events from the event queue if it is idle. If it is not idle, it cannot process events from the event queue.
Because it can't use a second thread
Because there is only one thread, yes.
One at a time.
One at a time.
Yes, exactly. Even multi-threaded applications, like C#, for example, have restrictions on the. They differentiate threads. There's the UI thread. There's only one thread, the UI thread or the main execution thread, and there's all the other threads. So And there is a restriction that you can only manipulate UI controls from within the UI thread. You cannot manipulate UI controls from other threads. Because experience showed that if you do, then bad things may happen. A few years ago, you could manipulate, you were allowed to manipulate UI controls from other threads, but then unexpected things could happen. Because the controls might be in a state other than the state of the last line of code that changed them, modified them in the UI thread. But anyway, to return to JavaScript, since we only have one thread, yes.
So whenever you finish, just tell me, because I need to ask them about their homework and stuff like that.
Yes, I think we're pretty much finished. Let's see if there's.
Can you put this to the Slack?
What?
Put this to the Slack. To the Slack. This code. Copy paste to the Slack.
To Slack? Yes, sure.
+7.
But I have to log in and.
Okay, he has a question.
Yes, please.
In case, like you have said that it is taking 5 seconds to load, then how can we make it keep that command?
How can you make what?
How can we code so that it can keep the command, not to leave it? You understand?
What do you mean?
Like you say, when you click the first command, it will load. See that? After 5 seconds, it will.
Here,
Yes.
the slow function will execute. This line of code will be executed millions or billions of times, right? And it will stop executing when we reach the predefined time, right? Which is 5 seconds later from the time it was started. We don't know how many times this line of code will be executed. It does nothing, but still it's a line of code, right? The processor will execute it. And it will execute it millions or billions of times. Even if we have only 5 seconds, because processors execute lines of code extremely fast, right?
Okay, but the point, the point
Yes.
is to avoid these procedures.
To avoid blocking user interface. What do you do?
Yeah.
Yes, good point.
Because this is bad habit for the user.
Yes, you told us that it's not a good idea of using this, but you will show us a way to play around it. So what's the
Correct.
function, basically?
Correct.
That's the important.
So, first of all, if you need to run something that is computationally intensive on the front end, you can do nothing at all. If you do need to calculate, to start crunching big amounts of data in numbers in the front end, then there is nothing you can do. User interface will become unresponsive. But there are, it is a very rare thing if you have to do so. Because most of the times, calculations are delegated to the backend. Slow calculations are delegated to the backend, usually. Okay. It really depends on the nature of the application that we're building. For example, if we're building an application that has a 2D or 3D, let's say, user interface, like I'm doing right now, I'm playing with WebGL and 3D graphics, then there is nothing I can do. I have to optimize in order to not let the user interface become unresponsive, right? But this is a very rare thing. In most applications, if you are careful, you will never block the user interface, because what takes time? Let's see the kinds of computations or requests that take time, right? Number one is requests to the server, right? We do not block this because we use XML HTTP requests and promises, like we saw the previous lesson. Promises will not block the UI because what you do, what are we doing with the promise? We're giving a handler to be executed when the promise is fulfilled, right? But while the promise is pending, it does not block execution. Execution continues. And when the promise is fulfilled, then, just like we saw here, then that code will be run. In the meantime, the user interface is not blocked. So this is the most usual thing that you'll encounter. Calls to the server. What else? With events, in event-driven programming, you attach event handlers to events, right? If no event is triggered, then no code runs. So this is a very rare thing to find in front-end code. You don't have these things in front-end code. Most usually, everything executes very fast, and execution finishes, and then the user in the JavaScript runtime sits idle, waiting for the user's next action. If I was to write, let's say, an algorithm that calculates prime numbers or whatever, and it is slow, then we would block the user interface, yes. But in real-life applications, these kinds of workload is delegated to the backend. And the front end is just a thin client in order to present information to the user. Let's see what's next. If we need to delay execution of code, we can do so. There might be cases, it's not rare, it's very often, that we might need to delay execution of code for 1 to 5 seconds, let's say. We can do that by using the timeout function. For example, if I click the first button, I want to display an alert 5 seconds later. And I do that by using the timeout function. The timeout function takes 2 arguments. The first argument is a callback. This is a timeout function. The first argument is a callback, and I'm using the fat arrow syntax here. Is it okay? Is it clear with you? It's the same thing as doing this one. Display alert. So the set timeout function expects 2 things. The first thing is the callback function to be executed, and the second argument is the delay in milliseconds. So if I refresh here, I click the first button, and the alert pops up after 5 seconds. But notice here that, do you see that buttons get
So it doesn't block.
It does not block, yes. So I click the first button, click the second button clicked, and then alert shown. Okay. So the set timeout function,
block the...
it doesn't block because it's let's go here.
Work like two threads.
Hmm?
Work like two threads.
It simulates the a second thread by requesting the browser. First of all, it's a browser facility. Let's see. Let's see it again. It's a browser API. See here? The setTimeout function is provided by the browser, not the JavaScript engine. So the browser starts a timer, and when the timer is triggered after the 5 seconds, it places the callback inside the event queue. And then the JavaScript runtime, because it is idle, sees that there is here an item in the event queue and takes it and executes it. But what if, after the 5 seconds have elapsed, the JavaScript runtime is still busy? What will happen then? Can you guess? Let's say that we add the set timeout here. Okay, set timeout for only for 1 second, right? Let's put it set timeout display alert, and I will schedule display alert to be executed 5 seconds later. But in the meantime, I'm going to click the second button, which will do a blocking execution of code for 10 seconds. Let's set this to only 1 second to demonstrate this clearly. Okay, so I click the first button, 1 second, alert pops up. Okay, click again, 1 second, alerts pop up. Let's also fix the alerts message so that we don't get confused. Okay, click, 1 second, alert. Click, 1 second, alert. But look now. Click the first button and then the second. Where is our alert?
Was low. 1 second, 5 seconds, 6 seconds.
Oh, here is our alert. Why was that?
So the duration in the time.
Because I clicked the first button, the browser's internal timer started counting the time. Okay. The browser, after it counted 1000 milliseconds, it put the callback function that pops up the alert in the event queue, right? But at that time, the JavaScript runtime was busy executing the slow function. So it could not process the event queue, right? So we set the timeout for 1 second, and we got the alert 11 seconds later. Why? Because the JavaScript runtime was busy for another 10 seconds, and it could not process events. So here.
Thank you.
For Monday, we have live stream.
No, from today from yesterday we started everything online. If you go to YouTube, our official YouTube channel, every day you can not only see your class, you can see other class on live as well.
Sorry, I have to go because I have a meeting with my account.
Yeah, sure. we're stopping live.